Okay, guys, so the next topic is going to be rectangles. So we're going to compare and contrast rectangles with parallelograms and see where they fit within the idea of quadrilaterals. So first of all, rectangles will inherit all of the properties of parallelograms. So the 5 properties that we discussed in the previous lesson, the rectangle has still got all of those properties. The reason for this is that technically a rectangle is a parallelogram. It's just a special kind of parallelogram, right? So remember, it satisfies all the properties of parallelograms. The opposite sides are congruent, that's true. The opposite sides are parallel, that's true. Opposite angles are congruent, is true. Adjacent angles are supplementary, right? And the diagonals still bisect each other. But in addition to those properties, we're going to explore a few more properties here. So the first thing that is noteworthy for a rectangle is the obvious thing, is that it's no longer sort of tilted, right? So normally we think of parallelograms as being sort of slanted or tilted in a certain way. But for rectangles, they're sort of upright. So they're upright. And the reason for that is because all 4 of these angles are actually going to be right angles. Okay, so that's what we're going to write in for the first property, is that all 4 angles are right angles. Okay, and by the way, if you wanted to prove that something is a rectangle, you can just show that basically the adjacent sides are perpendicular, right? So if you do a slope calculation for this and show that they're negative reciprocals, that's good enough to show that they're perpendicular, and therefore you're getting right angles. Okay. The second property that rectangles have that is very interesting for us is that the diagonals are congruent. So let's write in diagonals are congruent. So notice that if I draw a parallelogram, right, a general parallelogram which has some tilt to it, what we see is that this diagonal, notice how it sticks out further on the left side and the right side. So that means it must be longer than this one, which I'll draw in green, right? This one must be shorter because it doesn't have to sort of stretch as far, whereas this one does, you see. But when you have a rectangle, when everything is upright, it'll be the case that the diagonals will be of the same length. Okay? So effectively what happens is, since these bisect each other and they're the same length, all 4 of those inner segments are going to be equal. Okay? So let's see if we can now apply that knowledge in the first set of questions. Right, so the first thing I would realize is that since opposite sides are congruent, I can conclude this is 24 and this is 10. So this is the same thing as it would have been for a parallelogram. So let's write in QR as 10. Let's write in SR as 24. Now they're asking for the value of SQ. So in order to find SQ, what I need to realize is that I have a nice triangle that's been formed right here. And this triangle happens to be a right triangle. The reason why it's a right triangle is because one of the properties of a rectangle is that it has 4 right angles inside. So that we know it has to be a right angle. And since we're trying to find the third side of a triangle, which happens to be a right triangle, we can use Pythagorean theorem, right? So c squared is a squared plus b squared. And we remember that the side that is labeled as c has to be the longest side, the hypotenuse, the one that's across from the right angle. Okay? So we put that in as x. And then a and b actually doesn't matter. So I'm just going to use 24 to be a and then 10 to be b. And when you compute this in the calculator, you'll find that the hypotenuse is going to end up being 26. Right, so if you're curious as to how I knew that, basically I know about the 5, 12, 13 triangle, and this happens to be a multiple of that special right triangle, right? Because if you times each side by 2, you get those numbers that we have, right? So anyways, x is equal to 26, so that's SQ, 26. Now PR, since the diagonals must be congruent, PR also has to be 26. And then QT would have to be half the value of the diagonal, so it has to be 13 each, right? So let me just get rid of that 13 there. Okay, moving on. So this next question is talking more about the angles, and the first thing that I'll notice is that since this is 27, this one would also have to be 27. And the reason for that is basically that these are parallel, right? That's a property of parallelograms. And then I have a transversal over here. So these form what are called alternate interior angles. If I remove this, then my next step would be to try to figure out this angle. And so I know that if I do 90 minus 27, that will get me 63. And that will go here. And it would also go in this spot here. And the reason for that is, once again, these are alternate interior angles for the other parallel lines. Okay. So let's start filling some in. So MJK. MJK has to be 90 degrees. MJL. MJL is 63. JLK. So let's see. J to L to K. That's 63. KML. K to M to L. Okay, so now what we can deduce here is that this angle is also going to be 27. So the question that you might ask is, like, why does this happen? And what I can say is that we know that all four of these segments are going to be equal. And the reason why that happens is because diagonals bisect each other, and the diagonals are also congruent in length. Excuse me. So that means that we have all four of these segments being equal, and in particular, we have these two being equal. So if you look at this bottom triangle, we can conclude that this triangle must be isosceles, okay, because it has two sides that are equal. And then we can further conclude that these base angles of isosceles triangles have to be equal. So that's why this would have to be 27. Okay. So once we have that sort of down, then we, yes, can write in 27 for the next result. And then M and L. So let's look for M and L. So that's the top angle here. And if we add 27 with 27, that gives 54. And we take that away from 180. And that leaves 126 for that top angle, right? Because all three angles in a triangle add up to 180. All right, so here's the next one. So given that DB is 42, so right away I can conclude that each one of these would be 21, and also these. Okay. AD is equal to 26, so I can conclude that this would be 26. The measure of angle DAE is 52, so DAE is 52 degrees. Then I can conclude that this would be 52, and so would these ones here. Okay. Let's see what they want us to find. So AC, okay. So AC would also have to be 42, right? EB would be 21. BC would be 26. AB, okay, we didn't compute that yet, but we can do it. So the first thing that we might look at, yeah, basically to find AB, we can realize that we have a right triangle here. So in this right triangle, we have an unknown side, which we'll call x. The long side here is 21 plus 21 is 42. Here we have 26, okay? So we would use Pythagorean theorem. And remember that the c side has to be the longest, which is 42. So we have x squared and 26 squared. And now might be a good time to use our calculator. Save ourselves a little bit of work. So 42 squared, subtract 26 squared, and we square root the answer. Okay, so 32.98 for x. And that's close enough to make it 33. So let's just make x equal to 33. That'll be AB. And next thing they want is some angles. So angle ADC, angle A to D to C would have to be 90 degrees. ABD, so that would have to be 90 subtract 52, so that's equal to 38. Okay. BCA, so B to C to A, that's 52. And DEC. So DEC is this top angle here. So we would expect for these to also be 38 everywhere here, because of, alternate interiors and the isosceles triangle. And then when we have 38 and 38, that adds up to 76. Okay. And if we do 180 minus 76, that would equal 104 for that top angle. So we can just fill in 104 for that. Okay, so now it's your turn to try numbers 2 and 4.